In this tape, we're going to be continuing our work with rational expressions or fractions. We're going to reduce fractions using factoring, continue our work with addition, subtraction, multiplication, and division of fractions, solve some more complicated fractional equations, and then go on and solve some formulas. The key to working with fractions or rational expressions is, of course, the fundamental principle of fractions. Which we have seen before, and which says basically if you have a fraction and if you multiply the top and the bottom of this fraction by the same non-zero quantity, we get an equivalent fraction. Or, that's reading in this way. Reading the other way, if we have a fraction and we divide the top and the bottom by the same non-zero quantity, we get an equivalent fraction. When we work in this form, in this direction, okay, we build fractions to higher terms. Usually we build fractions to higher terms, usually for the purpose of adding fractions. And when we're working in the other direction, we reduce fractions to lowest terms. Okay, let's use the fundamental principle of fractions to reduce fractions by means of factoring. If we have 4x squared minus 12x over 2x minus 6. Okay, in order to reduce this to lowest terms, we have to factor separately the numerator and the denominator and then look for common factors. You do not try right away canceling 2x's and the 6, because 2x and 6, these are terms downstairs, not factors. Okay. On the other hand, we can factor the denominator. There is a common factor, which is always the first thing we look for, namely 2. And we can rewrite this as 2 times x minus 3. In other words, two factors downstairs, 2 and x minus 3. Upstairs, there is a common factor of 4x. And if we pull that out, we're left with x minus 3. So 4x squared minus 12x over 2x minus 6. In this form, we can use the fundamental principle of fractions. We see that we can divide top and bottom by x minus 3, which is a factor, and we're left with 4x over 2. And then, of course, we can divide top and bottom by 2. 4 divided by 2 is 2. 2 divided by 2 is 1, giving us 2x over 1, or a final answer of 2x. For our next example, let's try x to the 4th plus x squared over x squared. Okay, a lot of people make the mistake of canceling the x squareds. They forget that x squared is a factor downstairs, but it's a term upstairs, the way it's written now. And you cannot just cancel the x squareds. Some people just cancel, they get x to the 4th or x to the 4th plus 1. That's incorrect. The correct procedure is to factor out the common factor upstairs, which is x squared. That leaves us with an x squared plus 1. That's x to the 4th plus x squared over x squared. And now, using the fundamental principle of fractions, we can divide top and bottom by x squared. And that gives us a final answer of x squared plus 1. Okay, how about this example? X squared plus 4x plus 3 over x squared plus 3x. We separately factor the numerator and the denominator. Always, when we try to factor, the first thing we look for is a common factor. Well, upstairs there is no common factor. However, we have had experience with trinomials like this, and we hope to factor it into the product of two binomials. The lead coefficient is a 1, so we can just write that as x, and we're looking for two numbers which multiply to plus 3 and add to plus 4. And they are plus 3 and plus 1. And checking by FOIL, we multiply, we get x squared plus 1x plus 3x. That's plus 4x plus 3. Downstairs, there is a common factor, namely x, which can be taken out, leaving us with x times x plus 3. Okay, we can now apply the fundamental principle to divide top and bottom by x plus 3, which is a common factor, leaving us with x plus 1 over x. And that is where you stop. Don't be overzealous here. Don't now cancel the x's. Remember, x is a factor downstairs. The bottom is really x times 1, but it's a term upstairs. Okay, it is not joined to the 1 with multiplication, but rather with addition. So it's a term upstairs and a factor downstairs. So you cannot go any further on this problem. Okay, how about x squared plus 4x plus 4 over x squared minus 4. Okay, you have to resist the temptation to cancel the x squareds or cancel the 4s, because what we have here, these are terms. We must first factor the top and the bottom completely, and then we'll cancel the common factors, not terms. Okay, upstairs there is no common factor that we can pull out. However, we can write it as a product of two binomials. We're looking for two numbers which multiply to plus 4 and add to plus 4, and they are plus 2 and plus 2. Checking, we have x squared plus 2x plus 2x plus 4x plus 4. Downstairs, we're looking for two numbers which multiply to minus 4 and add to 0. So they are x plus 2 and x minus 2. Or we recognize this is a difference of two squares, a squared minus b squared, which factors into a plus b times a minus b. Checking by FOIL, x squared, the minus 2x, the plus 2x cancel, giving you 0x, which does not appear here, and then the minus 4. We can now divide top and bottom by the common factor x plus 2, leaving us with x plus 2 over x minus 2, and that is as far as we go. We cannot cancel the x's or the 2's because the x's are terms upstairs and downstairs, and so are the 2's. Okay, now we've gone over reducing fractions using factoring. The next thing we will review is multiplying fractions. A over b times c over d. The procedure when we're multiplying fractions is to multiply the numerators and divide by the product of the denominators. Now, we would want to reduce our answers to lowest terms. And while you can do the multiplication first and do the reduction afterwards, it is to your advantage before you start the problem, if you can do any canceling, to start by reducing as much as you can. For example, let's say we have 8x cubed y to the 4th over 3x squared z cubed times 9x z squared over 6y squared z. If you wanted to, you could just do the multiplications and then try to reduce. On the other hand, you can do some reduction first. Let's see. 8 can be written as 2 times 4. We have here x cubed y to the 4th over 3x squared z cubed. 9 is 3 times 3 xz squared, and 6 is 2 times 3 and y squared z. Let's see what we can cancel out. And we can cancel any factor in the numerator with any factor in the denominator, even if it's not the one right underneath it, because actually what's going to wind up is that we have one big top over one big bottom. So it doesn't matter. Anything upstairs can cancel anything downstairs. Okay, we can divide top and bottom by 2. We can divide top and bottom by 3. Again, top and bottom by 3. We can divide top and bottom by x squared. X squared divided by x squared is 1. X cubed divided by x squared leaves you with x. We can divide top and bottom by y squared. Y squared divided by y squared is 1. Y to the 4th divided by y squared is y squared. We can divide top and bottom by z squared. Z squared divided by z squared is 1. Z cubed divided by z squared gives you z. And let's see if there's anything else that we can cancel out. Let's see what's left. We have a 4x y squared times x. So 4x squared y squared over z times z over z squared. So our final answer is 4x squared y squared over z squared. Okay, let's try the next problem. X plus 2 over x squared minus 2x times 2x minus 4. Two x minus 4 there is really 2x minus 4 over 1. So once again, it's like multiplying two fractions. First, let's factor. X squared minus 2x is a common factor of x, so it's x times x minus 2. 2x minus 4, there's a common factor of 2. 2 times x minus 2. So we can cancel the x minus 2's. These are common factors, dividing top and bottom by x minus 2. And that leaves us with 2 times x plus 2 over x as our answer. Okay, let's try the following. X squared minus 7x plus 6 over x squared minus 1 times 4x plus 4 over x squared minus 36. Okay, so what this turns out to be really is 4 separate factoring problems to start with, and then we will try to cancel the like factors, and then we will multiply the fractions. Okay, first we look for a common factor. In the upper left here, there is no common factor. It is a binomial which factors if you can find now two numbers which multiply to plus 6 and add to minus 7. Okay, so minus 6 and minus 1. Multiply to plus 6, and they add to minus 7, giving us x squared minus 1x minus 6x minus 7x plus 6. In the bottom left here, we have no common factor, but we have a difference of squares, which would therefore factor into x plus 1 times x minus 1. A squared minus b squared factors into a plus b times a minus b. In the upper right, there is a common factor of 4, which can be taken out, leaving us with 4 times x plus 1. And on the lower right side here, we have a difference, once again, of two squares, a squared minus b squared, which can be written as a plus b times a minus b, or x plus 6 times x minus 6. Now let's see what we have in the way of common factors. We can divide top and bottom by x minus 6. X minus 6. X minus 6. We can divide top and bottom by x plus 1. X plus 1, x plus 1. We can divide by x minus 1. And that leaves us with 4 upstairs over x plus 6 downstairs. And that's as far as we go. By the way, if the 4 had canceled out, if everything cancels out, there would be a 1 upstairs. Because when I write a line here, it's really x plus 1 divided by x plus 1, which is 1, x plus 1 divided by x plus 1, which is 1. So the slashes are really leaving us with 1s, not 0s. Okay, now if you want to divide fractions, a over b divided by c over d, the rule is that we invert and multiply. A over b times d over c, or we multiply by the reciprocal. A over b divided by c over d turns in we multiply by the reciprocal, or we invert and multiply by the d over c. So that's our basic rule for dividing fractions. Let's use that. Let's say we have x cubed y squared plus x squared y cubed divided by xy, then divided by x squared y squared. The first thing to realize is that x squared y squared is really x squared y squared over 1. So it fits into this mold. And we have this is equal to x cubed y squared plus x squared y cubed over xy. Instead of dividing by x squared y squared over 1, we invert and multiply by 1 over x squared y squared. And we then factor. Upstairs on the left side here, we have a common factor of x squared y squared that can be pulled out. X squared y squared, leaving us with x plus y over xy times 1 over x squared y squared. Well, we can divide top and bottom by x squared y squared, leaving us with x plus y times 1, or x plus y upstairs over x times y downstairs. And this is as far as we go. We cannot cancel the x's or the y's because the x and y are terms upstairs and factors downstairs. Upstairs they're joined by addition, downstairs they're joined by multiplication. And we have to leave it in this form. Okay, let's try the following. 5x squared minus 25x over x squared divided by x squared minus 6x plus 5 over 2x. We're going to first rewrite it as a multiplication problem. So 5x squared minus 25x over x squared times, now inverting and multiplying, 2x over x squared minus 6x plus 5, and now the factoring. The upper left part, we have a common factor of 5x, which can be taken out, leaving us with x minus 5. Downstairs we have x squared, or x times x. 2x is already factored. And here we have no common factor. However, we can write this as a product of binomials. The lead coefficient is 1. So we have x and x, two numbers we need which multiply to plus 5 and add to minus 6. They are minus 5 and minus 1, giving us x squared minus 1x minus 5x minus 6x plus 5. All right, we can now cancel the x minus 5 factors. We can divide top and bottom by x, again by x, and that leaves us with upstairs 5 times 2, which is 10, downstairs x minus 1. So a final answer of 10 over x minus 1. Okay, we've gone over multiplication and division of fractions. Now for addition and subtraction of fractions, the basic principle is that if you want to add two fractions, they have to have the same denominators. And if they have the same denominators, you can combine numerators and put them over in the same denominator. And the same thing for subtraction. If you want to subtract two fractions, they must have the same denominators. You combine the numerators, put it over the common denominator. All right. Let's try an example. 2x minus 4 over 3x plus 6 minus x minus 6 over 3x plus 6. So this comes under the category a over c minus b over c. According to our rules, we are to combine the numerators over the common denominator. Now the common denominator is 3x plus 6. However, when you want to combine the numerators, since these are binomials, there's more than one term here, you need parentheses. You have to write this as 2x minus 4 take away x minus 6. You can put parentheses. If you feel better, you can actually put parentheses around both. However, it's not essential that you have the parentheses here. Here, however, it's very important. If you just write minus x minus 6, you won't remember that the minus is to be distributed through each term here. So it's a minus b over c. And then we say 2x minus 4. This is really a minus 1 to be distributed through the parentheses, so minus x plus 6 over 3x plus 6. Don't forget we have to change the sign of each term here, so it became minus x and plus 6. That gives us now 2x and minus x combining like terms. That's 1x minus 4 and 6 plus 2 over 3x plus 6. And we can reduce to lowest terms if we realize that the top can be left alone. The bottom has a common factor of 3, so it's 3 times x plus 2. And we can divide top and bottom by x plus 2, giving us not 0, but 1 over 3. Remember, x plus 2 divided by x plus 2 gives you 1 here also, so it's 1 over 3, or 1/3 for our answer. Okay, now I have said there's rules for adding and subtracting fractions, only valid when the fractions have the same denominator. If the fractions do not have the same denominator, we must use the fundamental principle of fractions to build equivalent fractions to the ones in our problem, all having the same denominator. Okay, let's try the following example. Let's say we want to add 3 over 2x squared and 4 over 3x squared minus 6x. If you are adding thirds and quarters in arithmetic, you combine over the lowest common denominator, which is 12, and you build two fractions equivalent to the original ones, having the same denominator 12, and you then add the numerators. Here, we must similarly determine what the lowest common denominator is. The trick is to factor each denominator completely. 2x squared is 2 times x, 3x squared minus 6x has a common factor of 3x, which can be taken out, leaving us with 3x times x minus 2. 3x squared minus 6x. And the lowest common denominator, okay, is found by taking each factor the greatest number of times it appears in any one of the denominators. So 2 appears here once, here not at all, so we'll need it once. 3 appears here once, here not at all, so we'll need it once. X appears here twice and here once, so we'll need it twice. The greatest number of times, you don't add up the number of times, but the greatest number of times it appears